Welcome to Jason Howald's Colab Quickstart. This is a quick introduction to Colab, Jupyter Notebooks, Python, and Pandas. Now, since most of those technologies are probably new to you, I'd like to do a quick overview of what each one is. Python is a computer programming language. It's modern, it's very popular, and it's used in machine learning, data analysis, and web programming. Now, this is not a programming course, and we're going to be using Python mostly as a very fancy calculator. Jupyter is a framework for working with Python code. Jupyter notebooks are interactive. They have text cells for comments and explanation, and they provide rich output in the form of images, graphs, sound files, and whatnot. Colab is Google's service for Jupyter hosting. What does Google bring to the table? Well, cloud computers execute all of our Python code instead of running on our own computer. Notebooks are shareable like Google Docs, and various bonus features are available. Let's jump into Colab. I'm going to use my Professor Howald account and start from a blank page. We're going to go to colab.research.google.com and see what happens. We're going to see recent files. You probably won't have any if you're just beginning, and a welcome to Colaboratory introduction file. We're not going to view this right now. We're going to create our new Python 3 notebook. Now, what can we do here? This Flask is a controller that helps us opt into the new features or return to the classic experience. I suggest that you stay opted into the new features of the editor so that you and I will have the same look and feel. We can share Colab notebooks just as we would any other Google Doc. This is convenient, especially if you need homework help. You can share to Professor Howald at gmail.com. We can also create new text cells and new code cells by these things. We can also click between them if we want to create them in a particular location, and we can create new code cells or text cells that way. Now, I'd like to show you how we use this as a calculator by doing a very simple calculation, 2 plus 2. In order to execute this code cell and ask the computer to actually evaluate this, I'm going to press Shift Return on my laptop. You can also press this play button here. Now, it takes a couple seconds to execute, which might feel a little disappointing, but in those few seconds, the Colab servers have created a virtual computer in the cloud. That virtual computer has been tasked with the chore of calculating 2 plus 2 and has returned us, fortunately, the correct answer. Now, if we wanted to store that answer for later, we could simply copy it out of here, but a better solution is to assign it to a variable name and write x equals 2 plus 2. This assigns the name x to the result of this calculation. If I press Shift-Enter again, we might be somewhat surprised to see that there's no response. That's because Colab has basically shrugged and said, well, you want x to be 2 plus 2. It will be, but you didn't ask to see it. If we want to see x, we can go to a new line in this code cell or to a new code cell and evaluate the symbol x. If we evaluate the symbol x, then we'll see its value. Now, let's start with some of the statistics we'll need for class. I'm going to delete some of this nonsense, and I'm going to import pandas. Now, Python is a very powerful programming language, but it doesn't have statistical processing power built into the foundation of the framework. We need to import a package in order to have access to all the statistics, and the package here is called pandas. This name basically asks Python to go out and fetch the package called pandas, load it so that we have access to it, and give it a short form name PD so that we can refer to it as PD. That's a short alias for the package pandas. Now, what is statistics without data? We won't be able to show any statistics unless we can get some data into this Colab Jupyter notebook. So let's go get some data. Now, since we're using the Open Intro textbook, we're going to choose data from the source, which is openintro/data. I did it wrong. There we are. openintro.org/data. ACS12 is an interesting data set. If we click through, we'll get a data manifest here. It tells us roughly what the data is about, what variables are available in the data, where the data comes from, and gives us the option to download it. Now, you might think that we would click the CSV file and download it. We can do that. We can double click it. It will probably open in Excel. That's not what we're going to do here, because what we want to do is we want to somehow take this CSV file and get it into our Jupyter notebook hosted in Colab. How are we going to do that? We're going to copy the location of the CSV file. So I'm right-clicking on the CSV file, and I'm going to do copy link address. That's going to give me a URL to that CSV file. And then I'm going to command the Jupyter notebook to download that file. I'm going to use pd.readcsv. Now this is a sort of a cryptic command here, but well, we'll get used to it because we'll be doing this a lot. We're going to use quotation marks here, double quotes or single quotes, doesn't make any difference. And then I'm going to paste the URL for the CSV file that I just identified here. Now when I execute this with Shift Enter or push play here, the Colab notebook will actually follow this link, pull the CSV file, and then read it into something called a data frame. It will also, so I made a mistake here. I need to execute this line so that pandas is imported and actually called PD, and then I can execute this line, and then it will do what I said. So the Colab notebook has downloaded this CSV file and is returning to us this huge structure here, which is called a data frame. It has many, many, many different cases, and it has many variables recorded about each case. And we're not going to get into the details of what each of these variables means because it's not the point right now, but I want to show you one of the most common commands that we'll perform on this data frame. Unfortunately, I can't easily show you the command here because although I loaded the data frame, I didn't give it a name. Just like when I calculated 2 plus 2 but didn't assign it to a variable x, I couldn't refer back to that value. So what I'm going to do here is I'm going to give this a name. I could call it x, but since it is actually a data frame, I'm going to give it a slightly more descriptive name. I'm going to call it df. You could call it anything you want. Now when I execute this line, just as before with Shift Enter, suddenly I get no feedback from this line. But that's all right. I can make a new code cell below, and I can type df, and I'll get the feedback that I might have expected. Now I have a data frame called df, and it contains all this information. Now what might I like to do with this data frame? The most common operation that we'll do here is we'll ask for the descriptive statistics about this data frame. I'm going to type df.describe. I need a left paren and a right paren, and then I'm going to evaluate this. What this means is I want a basic statistical description of this data frame. I want you to tell me all of the easy statistics that you can calculate right off the bat. And you see what we get here is for all of the variables, income, hours of work, age, and time to work, which actually had numerical values in the data frame, I get a lot of statistical information. I get the average, the standard deviation, the min, the max, the count. Now, what else can I do with the data frame? I can produce a plot. Now, in class, there are lots of ways to produce plots. In class, we're going to be using the Seaborn package to produce plots. So that's another import. So I'm going to import Seaborn as SNS. And if it feels like there's a lot to memorize, these are basically the only two packages that we're going to use. I'm going to execute that. That's going to go off and pull the Seaborn package, which is used for nice statistical graphing. It's going to give that an alias SNS. And then I'm going to ask the SNS package to produce a plot. What should I plot? I'm going to plot the age variable of the df data frame. We refer to that this way, df.age. And this is going to give us a distribution plot. When I execute this, we'll see this is a distribution plot of the various ages of the people represented in this data frame. You see we have a roughly equal distribution of ages up to about 70, and then a drop off till about the age of 100. Well, this is just a quick example of a couple of the things that we're going to be doing quite frequently with Colab notebooks, and I hope it's been helpful to you. Thank you.